Hello, and welcome to the Wednesday, June 20th edition of the Cluster API Working Group Breakout Meeting for SIG Cluster Lifecycle. Today we're going to get started talking about different types of provisioners. Diwat, you're up.
Sorry, I noticed you rearranged the order. Okay, so Samsung has a need to provision to a number of different providers. And we've been looking at things like KubeCorn and then also the cluster control implementation as possible building blocks. One thing we're curious about is sort of like what the status of the various implementations are. So we've looked at like KubeCorn for AWS and where the platform 9 is looking at an SSH provisioner. These are both provisioners that we would be willing to write. However, we also have some other provisioners which we don't think, or we're not aware of anyone in the community being interested in writing, for instance, for MAS. So I have a couple of follow-up questions on how provisioners are structured in the wild. Like KubeCorn has a bunch of provisioners under one repo, and we're kind of interested in being able to maybe pick and choose different provisioners. But I think part of the first part of the question is, what is the status of like the KubeCorn AWS implementation? Chris, do you have any?
Yeah, totally. So like, I don't want to say the project's dead, but I definitely I'm pretty busy at the office right now with traveling for conferences and everything. And then Marco, one of the other main maintainers, he just started a summer with Google Summer of Code. So I would say if anything, the project is on reactive bug fixes only at this point. How that relates to this SIG and the work we're doing here is we have a tool called Cluster that lives in the Cluster API repository that effectively solves or attempts to solve the same problem as KubeCorn, although it doesn't work on AWS. I think there's two components that need to be addressed for spinning up and managing a cluster in AWS, which is the actual provisioning stage. How do we get to the cluster in the first place? And then the AWS machine controller that would read the cluster API and reconcile it. We have a hacky at best example of that in KubeCorn. I would really lobby for folks, if they're interested in working in this space, to write a more, what I would say, proper example of a controller, either in its own repository under Kubernetes SIGs, or we could build it in the Cluster API repository as well. And then that kind of segues into this whole concept of how do we start to break apart different actuators out of the main source tree, which we've lobbied on that for months now. So.
Yeah, and I have something later on the agenda to talk about that because DIMS is starting to try that. So I want to talk about that more. But I would say, it seems like there are a number of people that are working on some sort of AWS support for the Cluster API, but we don't really have a rallying place for that code to kind of come together at the moment. And since the Google implementation is in tree, and that's where the people at Google are working, we don't really also have an example of here's how you would set it up to be out of tree and how that works and so forth. Yeah. So that's definitely a problem that we need to solve. And maybe this is a good impetus for, let's set up a repo for AWS and start that process and try to get that machine controller working.
I think that's a great idea. I think KubeCorn has an example of what it's like to vendor the cluster API bits out of the repo, but I still think there's a lot more that needs to be solved there. And the controller is we can scale those, and that's all it can do. It doesn't even report status, so it's very primitive.
Yeah, hi. So while we are doing that, we might as well throw out the code that we have in a PR for the OpenStack to do exactly the same as well.
Yeah, Dim. So I put that a little later on the agenda. Maybe we can just talk about that now. So PR360, which I'll just move up, is related to how to get ClusterCuddle to use a provisioner that's not in tree, right? Because there's sort of two problems here. One problem is you vendor the Cluster API code out, and then you build your machine controller and so forth, and you get everything hooked up. But then how do you actually get ClusterCuddle to use that? And right now, it will only use the things that are compiled into it, which is rather unfortunate. So DIMS has a PR to basically allow you to register external providers into ClusterCuddle. Chris Rousey and I were talking about it yesterday, and the reason you have to do that is because there's an interface we have right now, because there are two things that Cluster Cuddle needs from a cluster. And ideally, it wouldn't need either of those things in the way it gets them today. And we'd have it sort of a different way to get those 2 bits of information. So one of them is where is the cluster located, so the IP address or the host name, and the other is credentials to talk to it. And right now, it's in the form of a kubeconfig file. And so if we had a sort of a different way to get those 2 pieces of information back, then we wouldn't need that interface, and we wouldn't have to link things in, which is, I think, where we want to go. For the first one, I think we have a pretty clear path forward of using the cluster controller to set that IP address, because then Cluster Cuddle can just look at the cluster object and extract that information to the API, which is great. For the credentials, I don't think we yet have a super clear story about how to do this. So we should figure that out. But in the meantime, if we do want to start building the OpenStack implementation and the AWS implementation out of tree, is probably reasonable short-term workaround to put your change in, with some comments basically saying, A, we are never going to expand this interface, and B, we're going to try to get rid of it completely.
Can we use a secret to throw in the information for the second part?
Yeah, so I think there's some ideas for how to do the second part. I just don't think it's clear what sort of the right way to do it is, right? So yeah, we could use a secret. We could make it, provider specific via SSH. Like, I think there are sort of a number of different things people have said we could do. We just haven't sort of built any of them and see that they would work. Because I think somebody has at least prototyped using the cluster controller to do the first one already. So we're pretty sure that's going to work okay.
Yeah, the other thing about my register lookup mechanism was that we still have the register part is happening in an init call. So we still have to put the package name somewhere in one of the Go files for us to be able to use it. So that is still one of the things that we need to figure out how to do better.
Right. So you're saying we have to put something for that provider in the main repo just to say that it's there. Right.
Correct. Yeah. So at this point, if you ask me to vote, what we have with the register lookup is better than what we have right now. Plus, it has the patch to get rid of the vSphere, the extra. We have an extra data structure for the 2 methods, get IP and the other one. So we should merge this and then take one more step forward, I think.
Yeah, I mean, that's basically what I was saying. Is I think this is a good intermediate solution to unblock people. But I just want to make sure everybody understands that this is not a long-term solution, and that we don't expect to ever make this interface any bigger, right? In fact, we want to shrink it and eventually get rid of it. Because otherwise, you do have to say, oh, we have AWS, let me check something in the cluster code repo. We have OpenStack, let me check something in, and that's not going to be scalable.
Right. So it's also a two-step tango, right? So the OpenStack repository will vendor in the cluster API, and then we will have to re-vendor the OpenStack code into the main repository and then add the package name. That's the short term.
Okay. Yeah, that doesn't sound great, does it?
No, it doesn't. But that's. So if we do that, then what will unblock is people here having to review the code in the OpenStack one. And the OpenStack code resides in a separate repository, and it can have right now people have been modifying the code for a while now, and there have been some attempts at reviewing it. The people who are doing the OpenStack code should probably take over that piece and not worry everybody else here.
Right. Where are you putting the OpenStack code? This kind of goes back to the question we had earlier.
I have a personal repository, but then since we were talking about the AWS one here, maybe we should start one here. There's at least 2 of us who will be working on it right now, but I'm aiming to get more people from the SIG OpenStack involved in this.
Well, I mean, maybe it'd be worth talking to like the steering committee about, or maybe just the SIG, setting up some repos for the different implementations. Mm-hmm. I think some people worry a little bit about repo bloat, about having too many, but certainly I had a chat with Tim a couple weeks back about that repo bloat in some ways was a good thing, because then every repo can be very focused and targeted and kind of like do one thing well.
Right. The template that I'm trying to follow is exactly what we did in the SIG Cloud Provider stuff. So do exactly the same. Like, we have a separate repository for each of the cloud providers out there. We can do a similar thing here as well, I think. We have precedent.
So, is it going to be possible to have two different implementations for AWS? And how can they be distinguished when registered?
I think the pattern I would lean towards prescribing here would be having a generic AWS or Amazon specific repository, and then having more than one either independent main function or just two different like modes of running the same controller. Similar to the way that Kubernetes can break out its different flavors of Amazon clusters as well.
Yeah, that sounds good to me.
Okay. I have a question for later.
Yeah, go ahead.
So on the next topic about sharing SSH scripts, this is related to breaking the repos out. Right now, when I look at the Google implementation, I believe also the vSphere implementation, and then all of the Kubernetes implementations, they all rely on Bash, Kubernetes, well, those two things in order to bootstrap nodes. Since we want to have a relatively consistent layer with which to build our additional services, like any applications or logging pipelines we deploy to these clusters, we'd like to make the Kubernetes deployment as uniform as possible, which means things like sharing those Bootstrap scripts. That's maybe made a little more awkward by having different repos. So, go ahead.
My question here would be, what do we gain from sharing Bootstrap scripts? Because I guess the reason I ask is when we first started doing this in COPS, we very much made it a point to say no users could configure custom Bootstrap logic that was an anti-pattern. And then in Kubernetes, we took the opposite approach and said, actually, no, we're going to give users all the power, and we're going to have independent Bootstrap scripts for every single different possible permutation of a cluster. And I'm wondering what we're trying to fix or solve by binding things together and having one uniform way here.
That's a good point. So actually, I'm not trying to insist on the Bootstrap scripts being the same between implementations, but I want, as a service provider, to be able to choose which Bootstrap scripts all of my users use. So maybe what I need is to be able to configure, like the Google implementation, to use my Bootstrap scripts, and then configure some AWS implementation to use those same Bootstrap scripts. That's not super easy right now because, like, Google implementation, if I recall, uses Golang templating with data in source to codify the Bootstrap scripts, whereas Kubernetes, for instance, has a scripts directory with a bunch of just bash files. Right? It's not clear how I can inject that same logic into the two different providers.
So the Google implementation, if you look under cluster cuddle, there's a config map called machine setup where that script lives. So you should just be able to put a different value into that config map to use a different script for starting.
Okay.
Yeah, it's just going to diverge, right? So once we have our own repositories, it's going to diverge even more than it is today. So I don't know if it makes sense to be able to say, take the bash scripts from one provider and use it in another provider. I don't think it'll work in the longer term.
But if Samsung wants to say, for our product, we want them to be consistent, it would be nice if sort of each of the providers had an easy way for them to sort of override those scripts. Like the Google one has a config map where they say, we're going to use the Google code, but all we need to do is put this config map in, and then it will run from that config map, so we can put our script that we know works.
Do we want to standardize on that, or that's the question, right? I mean, different people might have different ways of loading things up.
Right. So I think the key thing is to make it possible to override and make it configurable. I mean, if you look at the Google one right now, it's a template where there are definitely some substitutions going on, but those substitutions are run right now via a shell script with sed. And so what actually is put into the cluster is not templatized. What you see in the source code is templatized because it has things like your cloud project in it. But what you actually put in your config map is not templatized. So what the code is expecting is an untemplatized version. The code doesn't actually try to do anything more with config map, it just runs it. So that might be a good pattern for people to look at and see if it is more generally applicable. And if it seems like that works well, we could standardize it. And if it doesn't, then the implementations might diverge, but it would be good to make them all sort of pluggable in that sense. The other thing I'll point out, I don't think Justin is on the call, but COPS does have like a binary, like a Go binary that they run on the nodes instead of a shell script, which is another thing we might want to look at moving towards in the future. The shell scripts are nice in the sense that it's really easy for someone who's developing to see what's going on, but it's also a little bit harder to make them really reliable.
Yeah, they're harder to test. That was the other thing I was thinking, is I'd actually really prefer Bash right now, but I can see reasons to move away from that. It's hard to think how you can have language agnostic plugins. Right.
So two comments here. The more I've thought about how COPS has node up and actually has a Go binary that solves the Bootstrap problem, the more I lean towards this. I keep going back to this like idea that this might be in scope for kubeadmin. In other words, kubeadmin might actually be the right place to sort of build this logic into. And then the second, and that's a broader discussion for the SIG, just wanted to throw it out there. And then the second one here is, in general, the idea of using a Bootstrap script to pull information off the internet to bring up your Kubernetes cluster, I think is a really dangerous pattern as the internet can change. So I think, moving forward, I think the config map approach is solid, but I think we probably ought to encourage folks to start baking as much of this logic into whatever image they're using before they even bring up a cluster, so that we're not mutating the file system at runtime when we're bringing up a cluster. Just my opinions here for what they're worth.
Yeah, I mean, the more that you can sort of preload, the more reliable it is, and the faster it's going to be too, right? But that would also require people to have a pipeline of building images with the scripts all sort of pre-baked. And a lot of the times, the reason that there's a script is because things are parameterized, right? So you can't build an image that has a hard-coded IP for a single master, right? Or a kubeadmin join token, for instance. Like those have to be passed in somehow as parameters.
This is why we moved to writing the cluster API to disk on the nodes in Kubicorn. I'm not saying it's a good pattern, but at least that gave us one way of writing all of the dynamic information to one place. And then we could standardize on just expecting that dynamic information to be there with the rest of how we brought up the node.
Interesting. Yeah, so I guess what I'm hearing from this conversation is that there's sort of lots of different ways that people are starting to do bootstrapping of nodes. We've had, approaches in the past, both KubeUp and GKE use bash scripts. Kubicorn uses bash scripts. COPS uses Go binary. So there are pluses and minuses to the different approaches. I don't think we want to mandate that everybody has to do it a particular way, but if we do start to find sort of best practices, we should bring those back to the meeting and try to adopt those somewhat consistently across the different implementations.
Just one side note about COPS. It's actually using bash script as well to download the node up. And it's very nasty because it has to compensate, for example, for network outages. So in the bash, we have to do a retries and all those kinds of really bad things. So I think no one will escape the bash script.
Yeah, I mean, I guess you could get past that if you did have that node up binary preloaded on the image, right? You could say, I have an image, it already has kubeadmin installed, it already has a kubelet installed, it already has node up installed, and then all I need to put on that image is a couple of parameters that actually make those things do the right code paths, right, based on my particular cluster. Yeah, because our bash scripts have curl with dash retry right inside of it in multiple places. All right, so we've ventured a little ways away from sort of the original topic here, but David, does that answer some of your original questions, or did you have sort of more follow-on to do? I think we started talking about Kubicorn a little bit. Did you want to talk about like the Platform 9 SSH provisioner at all, or other provisioners?
If someone is on the line that can give status on that, I'm curious on whether we should start our own implementation of it. Since we require sort of 3 different provisioners at least, we're not going to start all 3 at once. And so I'm kind of trying to figure out which ones we want to focus on. Does anyone know what the status of the Platform 9 SSH provisioner is? Not sure who's on the line.
I don't know if they're here. I think last week or the week before they were, and we were talking about where to put the code. So it's sort of a similar question to what we were just talking about. And one thing we told them, that I think I told them, was that if we only had sort of a single maintainer for the code, that I wasn't sure it made sense to put it under like a SIG owned repository, because then the SIG would take the maintenance burden of it. But if you guys want to collaborate with them on that, then all of a sudden we have multiple maintainers across multiple companies, which is really nice and sort of much better fits the SIG model. In which case we should, instead of having them write the code in Platform 9 / whatever repo they wanted to create, we should put it in Kubernetes SIGs under a SIG Cluster Lifecycle repo and have you guys start working on it together there.
We would really like that. The SSH provisioner, I think, has some drawbacks, especially as in regards to security. But in terms of being able to quickly prototype new provisioners, it's gold.
Yeah, that was my main worry about the design doc that I read, was if you're relying on SSHN to clean up a machine without like going through a reinstall cycle, then you don't have great guarantees on what state that machine is in for the next person that comes along to try to use it.
I'd say you have zero guarantees.
Yeah, I was trying to be nice when I said no good guarantees. But I think, like you said, it might be great for getting stuff up and running quickly, and might be a stepping stone to having something a little bit more production ready for bare metal. So I think what I'm hearing here is, so for both AWS and for the SSH one, we should figure out how to set up a repo to get you guys started on those. So I will take an action item to follow up, or maybe I'll poke Chris. One of us will follow up and we'll try to figure out, we should have a sort of consistent naming structure for these repos where we're breaking things out into. And then we should start configuring those guys and giving you guys owners on them. Cool. Okay. Did that wrap up your initial set of topics?
Yes, thank you.
Excellent. Okay. All right, Martin, you're up next.
Okay. So it's about the pull request for adding a reference to the cluster in the machine specification from Matthew. I don't see him in the call, I think. Yeah, he's not here. Okay. So pretty much the reason why we need we need something like this is because the actuator, for two reasons. The actuator needs a reference to a cluster object, and the cluster object has some cluster-wide share data, pretty much. So especially for use cases when there are multiple clusters and machines in the same namespace for some reason, it should be, something like this should be added. So one approach of getting rid of this reference is either move more things to the machine, or there's no other way. Either we have the reference or we add things to the machine. So yeah, I don't see any problem with the reference thing right now. Just I'm thinking. Just right now, if anyone has any better suggestions about how to do it. So.
All right, I'm just pulling up the PR. I'm trying to remember which type of reference that the PR decided on, because we talked about a couple of different types of reference.
Currently it's Waco reference, but in my honest opinion, should be reference because the cluster object and the machines can be in different namespaces.
Feng, do you want to say something? Your mic is on and it's loud if you're not going to talk. Sorry, Martin, say it one more time. You said right now it's a local object reference.
Yeah, right now it's a local object reference, but I think it's much better to just have like an object reference or some kind. To have the possibility to specify namespace as well. So
yeah, I think that would be nice too, to have an object reference.
Yeah, but right now my main concern is either have a reference or just put things into the machine.
So, do you think it should be like an optional reference or like a mandatory reference?
Either, I mean, in this case, use case should be required. Otherwise, you cannot be 100% sure which cluster you're getting, because the current, for example, the current implementation in the machine controller, it fetches the first cluster in that namespace.
Yes, my question is, it also depends on the implementation, right? So the how, for example, in particular platform, for example, in GCP or it depends on the controller how everything working together. So in some implementation, maybe it's just optional thing. So because they will be shared only one cluster for the whole deployment. So
yeah, I mean, yeah, you can rewrite the entire machine controller, but right now the logic for choosing the cluster API, it's the cluster object is in the more or less the base outline of the generic machine controller. So
should be fine.
Okay. Did anyone else have any other comments about that? I think Martin was asking if there were any other options that people saw for how to move forward. If the two options on the table are put more things in machine or use a reference. Does anyone see any other sort of technical solutions that should be discussed before we focus on those two?
So I think there was also discussion on whether it should be compulsory or optional, right? And I think it makes a lot more sense if we keep it optional, because if you see in the last call also there was a question raised that what if you want to run a machine controller with existing like GKE clusters, so you want to attach your machine controller with the GKE's cluster and so on, right? So then if we make it compulsory to mention the details of the cluster inside the machine spec, then it's more or less unnecessary restrictions, right? So just thinking out loud, it might make more sense to have it a optional field in the machine spec.
I mean, I think it's certainly easier to move it from optional to required later than the reverse. So we could certainly start with it being optional and see if there are any cases where people like wouldn't want to use it, where we want to sort of keep it optional, or if we want to tighten sort of the screws as we move towards alpha and beta and say like, you know, we've sort of exercised the different use cases and we think this should always be required. So I think it would definitely unblock people to put it in and make it optional for now. And then we can see sort of how things shake out and see if it makes sense to keep it optional or to make it required later.
yeah, okay.
So Martin, do you want to respond to the PR and ask him to change the local object reference to an object reference and regenerate the code, and then we can try to get that in?
Yeah, I actually had a talk with him several days ago, so yeah.
Okay, great, thanks. Okay, so the next one I had was network addresses and machine status. So this was another one from Red Hat from Devin. I don't know if Devin is on the line today. I don't see him. So similarly, I think there aren't really any objections to this one going in. I think the only thing that I wanted to mention, which we had talked about on a previous call, is right now the IP address, he has it being added to the machine status. And it's not clear that it's sort of the right API design, but for services in Kubernetes, the IP addresses are in the spec instead of the status, because that allows you to request a specific address. And if you don't request it, then the controller will fill in what it assigned in the spec, which seems a little weird, sort of in the Kubernetes model. But we should sort of definitely check with, I don't know who the right sort of API reviewer cabal would be, but sort of where the right place to put this field would be. So Devin's not here, but I was going to mention to him that I think it's fine to put this in status for now, as long as we're aware that, since the API is still alpha, it might make sense to move it to spec later, or it might make sense to put it in both.
So I think you raise a good point. I just read yesterday something explaining how status is always read-only. And I think you do want to be able to sometimes choose your IP address. So I think it logically has to be a spec.
Right. So the question is if it's in the spec, do we have it in spec and status, or just in spec, right? So services just put it in spec, and the controller actually updates the spec, which is also kind of a weird pattern in Kubernetes. I don't think that's really followed anywhere else. And if it's if it's in spec and status, and a user doesn't request it, then now your spec and status are out of sync if the controller just sets it in status, but not in spec. And so I think there's sort of a weird case here where it's an optional field. So what happens with that? If the person's not requesting it, but it's part of spec, does the controller set it? And if so, does it make sense to have it in spec and status, or should we just leave it in spec? And I think that's sort of how the services one collapsed to just being in spec. So Tim, again, has mentioned on numerous occasions that the services design was done very early in Kubernetes is maybe not one to follow as a pattern. But I'm not sure what the right pattern to use is. So again, I'm happy to put it in status for now. I agree. I think there are cases where you'd want to specify it, and status is not the right place to specify something. So we might have to just move it around a little bit later. But again, if it's going to unblock people to put it in status for now, I'm happy to make that as an initial step. Unless someone, do you feel strongly we should just stick it in spec to start with? Would that make more sense?
I don't feel strongly, but I think it does.
I'll poke Devin on the PR and ask him if that would work for them.
I mean, the only reservation I have is you said that maybe service isn't the best thing to copy, and that was the example you gave. So
right,
maybe not the best argument, but it still makes the most sense.
Yeah, and that's where I'm saying, Tim has said don't copy services, but hasn't said here's what you should look at instead as how to do this. So that's all we have to go on right now. Okay, so I'll take an action to poke that PR and try to keep it moving forward. Next, as we were starting this meeting and I was looking for agenda items because the agenda was pretty light, I pulled up the pull requests and I noticed that there are quite a few pull requests that don't have an assignee, that are not marked as work in progress. And I know a lot of the ones from Googlers, people will just manually assign it to other people to review. And I think some people that are on this call will maybe get someone assigned because we discussed it during the call. But if people just send PRs, I think they might just sort of fly under the radar and not really end up with a reviewer and not end up making progress. So I know Kubernetes has a way to auto-assign issues to people. It appears that we don't have that configured in our repository. I don't know how to do that. I'm sure I could figure it out. But if someone is interested in sort of taking that on to figure out how we could set up an auto-assigner, that would be really awesome. Because I just want to make sure that sort of experience for people who are contributing code isn't that they send a PR and then it doesn't go anywhere because nobody happens to notice it.
Yeah, I can take care of that.
Thanks, Dems. That would be great. All right. So that was the end of our agenda. Does anyone else have things that they'd like to tack on at the end? All right. If not, we can finish a little bit early and let people start taking care of those action items in the last 20 minutes. Cool. Thanks, everyone, for coming. We'll see you guys again next week.
Bye, everyone.